Hello students, welcome to Sourav sir's classes. Today we are going to solve few numericals based on non-parametric methods. So let us begin with our first sum. So our first sum is based on sign test. So let's go through this sum. Question says use the sign test to see if there is a difference between the number of days required to collect an account receivable before and after a new collection policy. Use the 0.05 significance level. Okay, so here we have been given a table containing before and after days, and we need to find if there is a difference between the number of days using the sign test. So as we know, in sign test we first need the table completing the before and after collection policy. So let us draw one table here. So here is our required table, and as you can see we have a third row in this table saying sign of score. And how can we calculate the sign of score? We need to subtract the after row from the before row. That is, if we name this as 1 and this as 2, the sign of score will give us 1 minus 2, and not the value but only the sign of the value, the only the positive or negativity of that value. So as you can see, first 33 minus 35 gives minus 2, so here we will have a minus. Now 36 is greater than 29, so we will get a plus, and similarly we will solve each one of them. So here are our values. This will be 0 since 47 minus 47 is 0, hence we won't get any sign to it. Now this will be minus, this is again a minus, this is plus, this is again a 0, 34 minus 34 gives 0. Now this is minus, plus, minus, plus, minus. So here are the signs, positive signs and negative signs. So first let us count how many positive, how many negative and how many zeros are there. So here we have plus sign. So if we count plus, here we have 1, 2, 3, 4, 5, 6 and 7. So here it should be okay. So 7 is our minus sign, not the plus sign, so this will be minus. Now let's calculate the plus sign. So our plus sign here will be 1, 2, 3, 4, 5 and 6. So our plus sign is 6, that is 1 less from minus sign, and zeros are 1 and 2, so we have only 2 zeros. And as we know that in sign test we need to exclude this 0 part, because we do not need the 0, we only need the signs that are positive and negative, so we will exclude these zeros. So here we have total 13 usable responses. As you can see, here we have 7 and here we have 3, so total 13 usable responses. So here we have total 13 usable responses. So let us start finding our data. So here will be our first data. As you know, we need to first begin with the null hypothesis. Our first process begins with null hypothesis, that is the given in the question, that is h0 noted at h0 slash p, that is proportion, which is given in the question. As we know, it will be 0.5 if there is no difference. If there is no difference, it means that if it is h0 is equal to 0.5, then there is no difference. Or the second one is alternative hypothesis. This one is represented at h1. Here we have the value of p, which won't be equal to 0.5. Therefore it shows that there is a significant decrease, significant difference. So here is our hypothesis. Now let's begin finding our data. So for this sum, first we need the sample size. So here is our sample size. And what is sample size? Sample size is equal to the total number of usable data. Total number of usable responses here, as we have noted down, is 13, that is the sum of positive and negative. So here is our 13. The second will be proportion. we also need the proportion. Okay, sample size we can note this as n, and proportion this can be noted as p. And proportion, as you know, for positive we have p, which is given as 6 positive. As you can see here, we have total 6 in plus, so this is 6, and the n we will divide it by n, that is the total, which means the proportion of positivity is 0.46. And similarly the proportion of negative will be represented by q, which is equal to 7 by 13, or this can be written as 1 minus 0.46, which will give our value to be 0.54. So we have also got our proportions. So now you can find that whether we can use this whether we can use the normal distribution or not. So how can we find that? Determining whether normal distribution can be used. So we have a general form of finding this. What we need to do is we need to find the values of np and nq and find whether they are both greater than 0, greater than 5, or less than 5. If these two statements satisfy, that is if both of them have the value greater than 5, then we can directly solve this sum using the normal distribution. So let's check their values. np and n we have 13, p is 6 by 13, which gives us 6. nq, which is equal to 13 into 7 by 13, which is equal to 7. So as you can see, both of these values are greater than 5, hence we can use the normal distribution form and approximate the binomial. So let us proceed with our process. After this, what we need to do is we need to find the level of significance, and we have been given that in our sum, in our question itself. Basically its value is constant, which is 0.05, and also the value of z alpha is also constant for the two-tailed test. It can be two-tailed test, as you can see I have written above. If it is alternate hypothesis, here as you can see, if it is alternative hypothesis, then it is known as two-tailed test. It is case of two-tailed test, so we need to note down both the values of z alpha for two-tailed test will be 1.96. These two values are basic values, we need not to find them. These are the basic constant values of these two data. Now what we need to find is the standard error of proportion. We have found the proportion of our p, which was 0.46. Now we need to find standard error of proportion, which is noted down as sigma p, and the formula for this is pq by n. You just need to remember few formulas to proceed with this type of sums, and this is one of them, that is standard error of proportion, which is sigma p equal to root over pq by n. So let us find the value of using our values here. This is sigma p, which is equal to root over pq by n. So here you can see what are values of our p and q. So our p is 0.46 and our q is 0.54. So let's put the values here. This will be 0.46 into 0.54 whole divided by the value n. N is our 13, that is the total of positive and negative, and we have a root over. So solving these integers in between, below the root, we will get our value to be directly 0.2484. You can solve them on your own and match with your answer, match with our answer, and after root over it will give us value 0.498. So basically this is our value of standard error of proportion. Now all we need, the last process, is the finding of limits of acceptance range. What is acceptance range? Acceptance range is a range from which, let this be minus x and x, if our value of sigma p lies anywhere in between of this acceptance range, hence that is there is no difference in between the two types of collections, because here is our 0.05 significance. If we get our this error of proportion in between the acceptance range, hence we will need not to find any difference between the two types. Therefore there is no difference between the two types of collections. So let us find the acceptance range. So acceptance range, as you can see here, we have two limits, upper limit and the lower limit. So let's find both of them. So we also have a general form for this. Upper limit formula is P of H, that is the null hypothesis, plus Z, that is 1.96. This is the value of Z. Here I have written this, into sigma of P, which is, we have found our value, which is 0.498. that is the standard error. So this is the basic formula. So here we will have 0.5 plus 1.96 into sigma P, which is 0.498, as we have found it here. So solving this, we will get our value to be 1.476. So this is the upper limit. Now we need to find our lower limit for the total range, total acceptance region. So here we will have lower limit. So lower limit represented by P0, and since it is upper limit, we have a positive sign here. In lower limit we will have a negative sign, and the values will remain constant as it is. So here is our new equation. So let's put the values. 0.5, this time it will be minus 1.96 into 0.498. all the values will be same, but here since we have minus, we will get a lower value, and the value will be minus 0.476. So this is our acceptance range from, let me write this here, acceptance region lies from minus 0.476 to 1.476, and we need to check whether our proportion lies between this range or not. So you must remember the value of our proportion here. The proportion value P is 0.46. so let us write this here. The value of our proportion P is equal to 0.46, and you can see 0.46 is greater than minus 0.476 and is also less than 1.476. Hence 0.46 lies between these acceptance region. Hence there is no difference between the two types of corrections. Hence there is no difference in between the two types of collections, in between the two types of collections. So this is what the question needed, that we needed to find the difference, if there is any difference between the here we have the difference between between the number of days required to collect an account before and after new collection. So our answer to this question is no, there is no difference. So this is our answer to this question. So I will like to end this video here. You will find solutions to some other questions on this topic in our further videos.